Hello everybody, today we are going to talk about break and continue instructions in loops. Well, as you can see, we have got here a code from the previous lesson. And I remind you that code is sending to the output the multiplication table. Now I'd like to tell you what is responsible for the the external loop, and what is responsible the inner loop. Let's check it out. I will increase, for example, that guy to 15, and we will notice that we have got now 5 more rows. It means that the external loop is responsible for the amount of rows. When I decrease that guy here to the 5, well, notice that we have 5 less columns, so it means that this guy is responsible for the amount of columns. We'll also notice that when we are increasing number of rows, we are also increasing what? The length of column, right? Look, when we decrease that guy to, for example, 7, we'll notice that the column is shorter, right? So this guy is responsible also for the length of column. And this guy is responsible for the length of row. Okay. So, that's how it works. And now I'd like to tell you about the break and continue statement. Let's imagine a situation like that. I want to show all rows, all 10 rows, but row 5. So I don't want that guy here, right? When I build it, I want to have all rows but numbers 5, 10, 15, 12, and the 25. I don't want to see that guy either. What to do? In order to do it, we have to use the instruction continue. So if that loop with that variable here is responsible for the rows and we don't want to see that row, we have to check if I is equal to 5 and then use the continue instruction. Right now you'll see that we don't see anymore that guy here, the row 5. So we have achieved what we wanted to achieve. But how does it work? What is that guy doing here? Well, continue is working like that. Everything after continue instruction won't be executed. So everything after, so that guy's here, won't be executed. But loop will not end because of it. It means that we are skipping the code after the continue, and after it we are increasing I by 1. So we are increasing I by 1 and we are checking again if I is lower or equal to 10. Because it is true, we are again going to execute instructions. We are checking if I is equal to 5. No, because 6 is not equal to 5. And because of that, instruction won't be run again, the continue, because I will be increased, right? And everything after it is going to run like it was before. So it's good. Okay, so this is the continue instruction. It works like that. Now I'd like to tell you about the break instruction. What will happen when I do something like that? Break. As you can see, we can't see right now anything after the 5th row. So break is working like that everything after break won't be executed, and we are leaving the actual, it is very important that word here, actual loop. So our actual loop is right now that guy here, the external one. And because we are leaving it, it means that we'll run instructions here. Right? La, la, la. They will be run very well. But what would happen if I did something like that? If j is equal to, for example, 5, and I will do break here. As you can see, we lost all columns here because j is responsible for the columns, but all the rows to 10 were executed fine. So when our PC meets with the break, it is leaving that loop and it's going to execute that enter here, and after it will go to that incrementation here, it will check condition, and again. So it is leaving the actual loop. Okay, and what if I do the continue here? You'll notice that we don't have only the 5th column. That's how it works. And now I'd like to train a bit on, let's imagine a situation like that. I want to have right now one loop that will do the same as that 2 loops. Wow, how to do that? Let's comment that, guys, here. But we can do that because we have comments here. Let's delay that. Let's do that way. And now I will send to the output the first line, like before. So I++, and now cout with and cout I, and let's create the j here also, because we have only one loop, right? And as you can see, well, it's because of the line, I shouldn't add it here. We have got only one row. Cool. And if I wanted to have more than one row, I should increase the j, right? So let's do that. I'm going to increase j now. And what's going to happen? As you can see, we achieved wrong numbers here, right? Because right now we are increasing the j and we are increasing the I at the same time, and because of that we have got multiplied 2 by 2, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, 8 by 8, 9 by 9, and 10 by 10. Okay, so we should increase that guy only when our I is equal to 10. We can do that, but before that, no, it's not good. So right now we have only one row and everything works like we wouldn't have it at all here, right? Why? Because condition here, when I is 10, is not met, and of course that incrementation won't happen at all. Okay, so we should also assign 0 to I, so it will keep running, right? And right now let's see how it's going to happen. As you can see, it will run almost forever, so because our condition will never be right now false, because we always assign 0 to I when the condition is almost to be false. So we have to also check, we have to break, we have to leave from that loop when j is equal to 10 plus 1. I will tell you why the plus 1 is here soon. Break. We should also add enter after each of row. And as you can see, we have got right now multiplication table by using only one loop. Of course, that is a bit more confusing, at least for me, than that thing here, than nested loops. So it's a rather training of break. And let's see how it's working now. So right now we are multiplicating I, so at the beginning 1 by j, which is 1, and after it we are just skipping that guys here because the conditions are not true, they are false, and we are increasing I, we are checking condition, and we are multiplicating 2 by 1, 3 by 1, 4, 5, 6, 7, 8, 9, 10, and finally when it's 10 we are checking that condition is finally true, and we are increasing j, we are assigning to I 0, we are creating the end line, so we are creating the enter, and we are checking that condition which is not true, and again we are multiplicating now this time 1 by g, which is now 2, so we have got now 2, 2 by 2, 3 by 2, 4 by 2, and again when I is 10 we can increase that guy and but when finally g is 10, we are skipping some rows of course, when g is 10 we should also run that code, that multiplication here, because you want to see the 10th row. If I did it that way, you'll notice that we are not seeing now the 10th row, because we must remember that when our PC meets with the break instruction, we are leaving the loop, right? Because we have to add here the plus 1, because we want the 10th row to be also executed, right? To be also sent to the output. Okay, that's all in this lesson. Thank you very much.